In this lesson, I'm going to do a few examples on trigonometric functions of multiple angles. So before we start doing few examples, let's recall sine 2x is 2 sine x cos x, cos 2x is cos square x minus sine square x, and is also equal to 1 minus 2 sine square x, and then it can also be rewritten as 2 cos square x minus 1. Tan 2x is 2 tan x over 1 minus tan square x, and sine 2x is equal to 2 tan x over 1 plus tan square x, and cos 2x is equal to 1 minus tan square x over 1 plus tan square x. Now we are going to start with the first example. So we have to show that sine 2x over 1 minus cos 2x is cot x, and then we have to show 1 minus cos 2x over 1 plus cos 2x is tan square x. So for show that, I'm going to again start with left hand side. Most of the time we take the left hand side, but again it depends on the question also. Sometimes we have to take the right hand side. So in this case, because there are more expressions or trigonometric functions on the left hand side, so I have to start with left hand side here. So sine 2x over 1 minus cos 2x. Now we already know sine 2x is equal to 2 sine x cos x. As you can see from the right hand side, I just need x. So I have to get rid of 2x here. Now 1 minus cos 2x, we already know cos 2x is equal to either this or that one, or 2 cos square x minus 1. So I will highly recommend you to keep in your mind how to express cos 2x in terms of sine square x and in terms of cos square x. This is very important, and especially when you do the integration with a sine square and cos square x. This information, if you remember it, it's going to be super helpful. So I'm going to write this 1 minus 2 sine square x, which means 2 sine square x is equal to 1 minus cos 2x, and sine square x is equal to 1 minus cos 2x divided by 2. And similarly, or you can use only 2 sine square x, okay? Similarly, cos square x is equal to 1 plus cos 2x over 2, or 2 cos square x is 1 plus cos 2x. So from here you can see that I have to use this information, this 1 minus cos 2x is 2 sine square x. Now this 2 and 2 get cancelled. 1 sine is also going to cancel. So this is cos x over sine x. So this is equal to cot x. Remember, sine square x is same as sine x whole square. That's why when I cancel out 1 here, because it was sine x cos x, so this is 2 into, this is same as sine x whole square. So when I open this is 2 into sine x times sine x. So 2 got cancelled, sine x got cancelled. So this is cot x. Okay. Now the next one is 1 minus cos 2x over 1 plus cos 2x. Now we already have this information here. So 1 minus cos 2x is 2 sine square x. And 1 plus cos 2x from here you can see is 2 cos square x here. So again, I took the left hand side here, and the left hand side, the numerator of the left hand side is 2 sine square x from here, and the denominator is 2 cos square x. 2 and 2 got cancelled. So sine x over cos x, we know this is equal to tan x. Therefore, sine square x divided by cos square x is going to be tan square x. Okay. So the next one is we have to show that cos 4x is equal to 1 minus 8 sine square x multiplied by cos square x, okay? So we are going to again start with left hand side here. So this is equal to cos 4x, and I already know the formula for cos 2 theta, which is equal to, again, cos square theta minus sine square theta, and 1 minus 2 sine square theta, or 2 cos square theta minus 1. So we need to see that which formula should I be using here. So if I'll use this one, cos square theta minus sine square theta, then it might work actually. So maybe we can start with that. So this is cos square 2x minus sine square 2x, and then you have, because this cos 4x is going to be, so if I replace this by 4 theta, then this should be equal to cos square 2 theta minus sine square 2 theta, right? So the point is that if you have theta here, here you have 2 theta. So if I have 4 theta here, it should be 2 theta here. So we got cos squared 2x minus sine squared 2x. Now from here, I can factorize this because this is a square minus b square, which is a minus b, a plus b. So this is equal to cos 2x minus sine 2x. And then you have cos 2x plus sine 2x. Okay? But the problem here is that I'm not going to get what we need here, because this one a square minus b square, but I'm not going to get, I'm not going anywhere from this one. So maybe we should use the another one. Let's try 1 minus 2 sine squared theta. So if I do that, then cos 4 theta is going to be 1 minus 2 sine square 2 theta. And now I know that this is equal to 2 sine theta cos theta whole square. Okay, in our case theta is x, so 1 minus 2, then this gives me 4 sine square x and cos square x. So 1 minus 8 sine square x cos square x is my answer. So these questions with the trigonometric functions, when you have to prove certain identities here, then this show that questions can be very, very tricky. And the problem with show that questions are that how to get the right hand side of the statement, and which means we have to always like see that which one to choose. In this case, if I started choosing cos square theta minus sine square theta, as you could see that it was not taking anywhere. So that's why we need to use 1 minus 2 sine square theta, because when you have 4x, you get 2 theta, and then you will get 2 sine theta cos theta, and that will give me sine square and cos square x. So this is the one which we chose and which we should have chosen in the beginning. Okay, so the next one is show that 1 plus sine x minus cos 2x divide by 1 plus sine 2x plus cos 2x is equal to tan x. So I'm going to again start with left hand side. Let's copy down that first. Cos 2x, be careful. 1 plus sine 2x plus cos 2x. Now I already know the formulas for 1 minus cos 2x and 1 plus cos 2x. So I'm going to do is I will rearrange them so that I can see them together. And this is 1 plus cos 2x and plus sine 2x. Okay. Now, okay, so here also it is sine 2x. So this is sine 2x here. Okay. Now here 1 minus cos 2x, as we already know from the previous one, 1 minus cos 2x is 2 sine square x. So this is 2 sine square x plus sine 2x divided by 2 cos square x plus sine 2x. Okay. Now from here, sine 2x can be written as 2 sine x cos x, and this is 2 cos square x plus 2 sine x cos x. Now, I'm ready to take common from the numerator and denominator. So, from numerator, 2 sine x is common. So, I got sine x plus cos x. Okay, I took this out, this, and one of this out. And then similarly, here you get 2 cos x common, so you get cos x plus sine x, and this get cancelled, and it give me tan x. Okay, so this was 1 plus sine 2x minus cos 2x divided by 1 plus sine 2x plus cos 2x. Okay, let's move to the next one. So here we have cos x plus sine x divided by cos x minus sine x, and then minus cos x minus sine x over cos x plus sine x is equal to 2 tan 2x. This is what we have to show that. So I'm going to start with left hand side again, but as I am going to copy down this, I'm going to put a bracket here. Okay, whenever you have an expression consists of more than one term, or even if it's one term with negative, you always should put the bracket. Now, so we know that whenever we have a fraction, when we are here also we are trying to subtract the fraction, which means we have to make the denominator same, which means here I will multiply this by cos x minus sine x, so I have to do the same thing in the numerator, and here I'm going to multiply by cos x plus sine x, and here also I will have cos x plus sine x. Okay, Now this one, so whenever you have a fraction, don't like be afraid if the fraction is not a number. So here the fraction consists of trigonometric functions. So don't be afraid. We know that how to subtract or add the fractions, which means you have to make the denominator same. So that's the thing which you need to remember. Now here you can see this is a minus b and a plus b for both, which is equal to a square minus b square. And RA in this case is cos x and b is equal to sin x. So this gives me cos square x minus sin square x. So this is done. And now up for first one, I have cos x plus sin x whole square, and then I have minus, and I have cos x minus sin x whole square. Now let's open. We know a plus b whole square is a square plus 2ab plus b square, and we also know a minus b whole square is a square minus 2ab plus b square. So this gives me cos square x plus 2 sin x cos x plus sin square x, and then I have minus here cos square x, so a minus b whole square minus 2 sin x cos x plus sin square x. And then in the denominator, I already have cos square x minus sin square x. Now this one, cos square x plus sin square x is 1. So 1 plus, I'm going to write down this as sin 2x. And then I have minus, this is again 1, so minus 1. And then this gives me sin 2x again. And this is equal to cos square x minus sin square x. Okay? So this one and 1 get cancelled. This gives me 2 sin 2x and cos square x minus sin square x. And as we know that cos square x minus sin square x is cos 2x. So this gives me 2 tan 2x, and which is our right hand side. Okay. So the last question which I'm going to do here is we have to show that there is a square root, and then you have 2 plus again square root, and then 2 plus 2 cos 4 theta. Okay. And we have to show this equal to 2 cos theta. So let's start with left hand side. Let's copy down it carefully. So 2 plus 2 plus 2 cos 4 theta, and then we have square root around both of them. So first thing I'm going to do is I'm going to first simplify the first square root, 2 plus 2 cos 4 theta. Here 2 is common, so this is 1 plus cos 4 theta. Now here, this one, we already know that 1 plus cos 2x is 2 cos square x. So we know 1 plus cos 2x is 2 cos square x, which means 1 plus cos 4x is going to be 2 cos square 2x. So this gives me 2 cos square 2x, and then square root of that. So this gives me 4 cos square 2x, square root of this, and which is simply 2 cos 2x. So I got that. Now I'm going to go back. So this I'm calling, let's say this is 1 and this is 2. So this one is the explanation for number 1. And now I'm going to go back and substitute what I got when I simplified the first square root here. And now again, same thing. This is 1 plus cos 2x. And then this is 2 cos square x. So square root of 4 cos square x is equal to 2 cos x. Okay. So here, try to keep the same. If the theta is given in the question, try to use this as theta. So our x is equal to theta. So we got 2 cos theta, which is your right hand side. Okay. That's it for today's lesson. And if you like my lessons, please subscribe to my channel. Thank you.